Hello everyone and welcome to another Maths tutorial video. Now I'll be discussing Form 5 Additional Mathematics, Chapter 4 Vectors, Long Question, Example 5. By the way guys, this is the fifth and the final example I'm going to discuss in Chapter 4 Vectors, Long Question. Maybe in the future I will go through this chapter again. Alright guys, before that, if you haven't subscribed to the channel, please do subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future. Alright guys, without further delay, let's jump to the question now. It is given that vector AB is equals to Pi plus 6j and vector CB equals to 16i minus 6j, where P is a constant. Find the possible value or values of P if magnitude of vector AC is equals to 15. The points A, B and C are collinear. Alright guys, I hope you will attempt this question in the future. If you could manage to solve this question, well done guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solutions now. Alright guys, let's jump to the solutions now. Okay, we're going to start with the question A, where the question A required us to find the possible values of P if our magnitude AC is equals to 15. Okay, for that, how are we going to start to solve this question guys? Okay, let me show you. Okay, for the step 1 is we're going to find the vector AC over here. So how to find the vector AC? So if you look at the question over here, they have already given us the vector AB and vector CB over here. Okay, from here we can literally form our vector AC. So how are you going to form? Okay, let me show you now. Okay, vector AC is equals to vector AB plus vector BC guys. So if you want to form a vector, you need to follow their last letter. So make sure your last letter of the first vector is the same as the second vector of the first letter. Okay, so they should be the same. So in order to form a specific vector, if let's say this is a vector AC, should be equals to vector AB plus BC. So B is the last in the first vector and then the second vector BC is first for the second vector. Okay, I hope you understand the concept behind this. But then the question is only given as CB, not BC. So in order to change to BC, you need to times with the negative CB guys, which is minus. So AB, vector AB minus with the vector CB. Okay, proceed to the next step. So vector AB is given as Pi plus 6j and then you minus with 16i minus 6j. Okay, you times in the negative value. So you can combine the whole expression, which you'll get Pi plus 6j minus 16i plus 6j. Because negative you get here positive guys. So plus 6j. Okay, the P the component I you can group them separately, and the component J you can add them together. So from here you will get P minus 16 in a bracket I plus 12j. So this is your first step guys. Okay, we have already find our vector AC. So once you've already find the vector AC, now we can proceed this from this step to the next step, which we can find our vector. The magnitude of vector AC is equals to 15. So how are we going to find it? Okay, I'm going to explain in the second step. So the second step is form the magnitude of AC and compare with the magnitude AC equals to 15. This magnitude AC is equals to 15 is already given in the question guys. Now what we're going to do, we're going to form the magnitude within this expression P, in terms of expression P over here, and then we're going to compare with equals to 15. And then we're going to find the possible values of Y over here. Okay, continue to the next step. So how to find the magnitude, the formula? Okay, I'm going to show you a very short example. So it's if given as a vector A is equals to xi plus yj. So in order to find the magnitude A, you just square the x component and then plus with the y's component, x squared plus y squared, and then you square root them. So if it's given as vector A is equals to xi plus yj. By the way guys, this concept is applied for three-dimensional vector as well. By the way, for now we are only dealing with the two-dimensional vector, which is I and j. If you, let's say, handle with three-dimensional, which xi plus yj plus zk, so you need to apply the same formula, which is x square plus y square and plus with z square, and then square root with the whole value. So they are pretty similar concept. So proceed to the next step. So what we do, we substitute in the respective component of I and j over here. We take the magnitude value and then we square them. P minus 16 square plus 12 square, and then you square root, equals to 15. Okay, what we can do here is we can expand the inside bracket. So from here, you'll get p square minus 32p plus 256 plus 144, and then you square root the whole expression, equals to 15. Okay, for the next step, what you can do is you can square the whole expression in order to eliminate the square root over here. So you square the equation on both sides. So from here you'll get p square minus 32p plus 400 equals to 225. So how I get this 400? Very simple guys, 256 plus 144, that's how I got this 400. Okay, now what you can do, this 225 from the right hand side, you can move it to the left hand side, which you'll get negative 225. So when you calculate together with 400, where 400 minus 225, you should get your answer, p square minus 32p plus 175 equals to 0. Okay, as you notice here, we have already formed a quadratic equation guys. Okay, now we can proceed to the factorization method. So from here, you get p minus 25 in a bracket and then p minus 7 in a bracket equals to 0. So in this case, you have two possible answers of p guys, where is p is equals to 25 and p is equals to 7. So these are your final answer. Okay guys, we have already solved our question A. Okay, let's proceed to find the question B and find the possible values of p if the points A, B and C are collinear. Okay, let me turn into the next page. So please hold on for a moment. Okay, alright guys. So to make a point A, B and C are collinear, so we're going to form a relationship between vector AB and CB. So how are you going to form it? So I'm going to show you now, which is vector AB is equals to a particular constant times with CB. So this expression is sufficient for us to create a relation such that the point A, B and C are collinear guys. So this constant, you can add any variables. In this case, I use a constant lambda over here. You can use any other variables such as alpha, beta and so on. So it's up to you guys. So I use a lambda sign over here. Okay, what we're going to do in the next step is we're going to substitute in all the respective vector values over here. So for vector AB is pi plus 6j. So for vector CB is 16i minus 6j. So when you combine them, you get pi plus 6j equals to lambda in a bracket 16i minus 6j. So you're going to times in the lambda, so which you're going to get pi plus 6j equals to 16 lambda I minus 6 lambda j. Okay, what you're going to do guys, we're going to compare in terms of component I and component j respectively. Okay, continue to the next step. So we compare in terms of component I and component j to form a simultaneous equation. Okay, I hope by right now you should know the trend guys. So as you can see over here, we are dealing with the two variables. One is lambda, another one is p over here. So you should understand guys, when you're dealing with two variables, that means you need to form a two equation and then you solve them simultaneously. Okay, so let us continue. So in terms of component I, you can see here p is equals to 16 lambda. So this is your first equation. And in terms of j, as you can see here, 6 equals to negative 6 lambda. So this is in terms of component I, and this is in terms of component j. Okay, it's for your reference, guys. If you don't get this expression, I mean you don't get this how I got the comparison, so I just write here I and j for your reference. Okay, from here we can easily find our lambda value from equation 2. So from equation 2, so 6 lambda is equals to negative 6. So from here you get your lambda value is negative 1. So once you get your lambda value is negative 1, so it's very easy, guys. You can substitute into equation 1 to get your answer. So when lambda is equals to negative 1, so p is equals to 16 times negative 1. So and therefore you get your final answer is negative 16. So this is your final answer, guys. Okay, alright guys, that is all for my step-by-step working and solution for this question. Any question or feedback, feel free to put in the comment section below. And before that, please put down the comment section below, guys. How do you find out this question? Is it easy or difficult? And could you manage to solve this question? Okay, don't forget to put in the comment section below. If you like this video, please give a thumbs up. If you haven't subscribed to the channel, please do subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos. Alright guys, thank you everyone for your support, and I will see you in the next video.